Hi there, now we're going to look at a 4-variable Karnaugh map. Of course, with 4 variables we have 16 possible combinations, so there will be 16 lines in our truth table, and therefore also 16 lines in our Karnaugh map. So I'm just going to go ahead and draw that. Now hopefully you saw the previous video where we did the 3-variable Karnaugh map, so a lot of the information is going to be the same as far as how things map out. I'm going to review it slightly in this video as well. But the first thing we're going to need to do is make 16 cells, one for each output in our truth table. Now we're going to have 4 variables again, and they will be, of course, D, C, B, and A. Now the next thing we're going to do is put our variable information here, 0, 1. And now don't forget, our gray code here, or 1-bit changes at any given time, causes us to have this pattern along the top and along the bottom. So don't forget this here and this here, and again remember that these are in a slightly different order than we would normally expect them to be. Now the next thing we're going to do again is just map out or transfer the information from the truth table into the Karnaugh map, and it's going to work the same way it did last time. So for example, the first line of the truth table right here, 0, 0, 0, 0, will correspond to box 0, 0, 0, 0 in the Karnaugh map right here. And the second line, 0, 0, 0, 1, of course, would map right here. You just have to be careful as you go down the truth table to make sure you take the appropriate jumps in the Karnaugh map, and we're just going to take a look at those right now as I fill it. So we're going to start right here with 0, 0, 0. So I have 0, 1, and then 0, 1 if I do it in the order of the truth table. Then I have 1, 1, 1, 1. If they're all 1s, I guess it doesn't matter. Next, we jump down, so 1, 0, 0, 0 is the next one. That's going to be down here, and we've got 4 zeros. And finally, 1, 1, 0, 0 is right here, so we're going to pick up where we left off with 0, 0, and 1, 1. Alright, so now we're done. The information from the truth table is mapped to our Karnaugh map. Now again, we're briefly going to go over the rules. We want our loops or our groups to cover all of the ones in the Karnaugh map, and none of the zeros. Our loops have to be powers of 2, so groups of 1, 2, 4, 8, 16, and so on, in the biggest groups that you can to give us the more simplified terms in the expression. And like the last time, we're going to overlap if that allows us to make bigger groups. We just have to make sure that each one of the loops has a 1 that is unique to that loop, and that will make sure that we don't have any redundant terms. Now there's a few options here. I'm just going to start with this one right here. So we're just going to make one loop of 4. Now again, we're going to do what we did with the other one, and that is take a look at the domain of that loop. So if we look up, we take up this much real estate, and if we look to the left, we take this much. Now, because we're in this row, the D and C are going to stay, so the term is going to be D naught C, because the D is a 0 and the C is a 1. So that's going to be basically the term for this loop, is D naught C. Now my other option is to take a loop up here, and then we're going to do the same thing as examine the domain or the area that this loop covers. And again, I can see the A here is 1 and 1. It doesn't change, so the A will be one of the terms. Since the B changes, it's 0 here and it's 1 here, then that term is redundant and the B disappears. Now if I look over to the left here, I see that the C term changes, so it's gone. The D term stays the same, so it stays, and it's a 0, so that's going to be D naught. So that means the term for this loop is going to be D naught A. Now my third option is going to be, again, I'm going to make a loop of 4 right here, and again I'm going to look up and to the left. Now if I look up here, I can see that the B variable stays, so we're going to have a B in the term. The A, you can see here, changes, so it will disappear. And if I look over to the left, I can see that the C stays the same, so the C will be in that term, and since the D changes, 0 and 1, it will disappear. So the term for this blue loop is going to be BC. Okay, so now let's look at it all together, and I'm going to put all 3 loops back. So there's my green one, and the expression for that was D naught C. And after that, we looked at this one up here. And the expression for that was D naught A. And the final loop we looked at was this one here. Hopefully that's not too confusing now that they're all in. And the term for this one was BC. Now, you'll notice there's overlap in the loops. You'll notice all the loops are in powers of 2, which they're all loops of 4 in this case, which makes for smaller terms. There is overlap, but each one of those loops, the red, the blue, and the green, all 3 of them have ones that only belong to that loop. They don't all have to belong, but there has to be at least one of the ones that's unique. And if you've done that, then your overlapping is okay. So what that's going to give us is a final Boolean expression for this output that is BC or CD naught or A D naught. I've just rearranged them a little. But that's our simplified Boolean expression based on this 4-variable Karnaugh map.